in this problem, I am given an interval for a function. And I'm told that point A is A f of A, and point B is B f of B. So, I mean, I don't know what this particular function looks like, but if I was just graphing some kind of a function, here would be point A, here would be point B. This is A, that's B, x values. This is A, comma, f of A, and this is B, comma, f of B. And I'm asked to find the secant line AB. So this is point A, and this is point B, and the secant line is that line that connects them right there. And I want to find a tangent to the function in this interval A to B that is parallel to that secant line. So I'm going to start off by looking at my function and making sure that it is continuous in the domain that they gave me. So this function right here, I'll rewrite it so it's a little bit bigger, is the square root f of x equals the square root of x minus 1. And they're asking me in the interval 1 to 3. Well, I don't have any denominators. I do have a radical sign with an even index. I don't have any logarithms. So I really just need to solve to make sure that the radicand x minus 1 is greater than or equal to 0. So it's telling me that x has to be greater than or equal to 1. And that's just fine. That doesn't cause any problems with my domain because my domain includes x equals 1. So now I'm going to find the derivative of f. So I'm going to rewrite f of x as x minus 1 to the 1/2. So f prime of x is equal to 1/2 x minus 1 to the negative 1/2, which is the same thing as 1 divided by 2 square root of x minus 1. So looking at the domain of that, I do see that, well, I'm going to have the same thing with the radical sign there, where x has to be greater than or equal to 1. But also, this is in the denominator. So x cannot be equal to 1. So my domain for the derivative is 1 to infinity. But that's okay with our mean value theorem, because in the mean value theorem it says the function has to be continuous on the closed interval AB and differentiable on the open interval AB. So we have an open interval here, AB. I think we're okay. Well, actually, that's the domain. The open interval that we're looking at is 1, 3 from right there. So I'm being asked to start off with finding the equation of the secant line AB. Well, all right, I think a good place to start would be to find out what A is and what B is. So f of A is the same thing as f of 1, because this is our A right here, and this is our B right there. So that is equal to the square root of 1 minus 1. Well, that's equal to 0. So my point A, capital A, is the point 1, 0. F of B is equal to f of 3. Well, that's equal to the square root of 3 minus 1. So that is equal to the square root of 2. So my point B is the point 3, square root of 2. So if I want to find the slope, I'm going to go f of B minus f of A. Those are my y2 and y1. divided by b minus a, which is x2 and x1. So that is equal to, well, f of b would be radical 2 minus 0 divided by 3 minus 1. So that gives me radical 2 over 2. That is the slope of my secant line, A, B. And now I need to find the equation of the tangent line to F in the interval AB that is parallel to that. Well, all the tangent lines are going to have follow this equation of my first derivative. So I want to find the point C such that f prime of C, well, we know that would equal to 1/2. Well, let's do it differently here. Well, 1 divided by 2 times C minus 1, well, that's the square root of C minus 1, would be equal to radical 2 over 2, the slope of the secant line AB. So in order to find C, I think I will cross multiply right here, since I have a proportion, equal sign there, and I get 2 is equal to 2 radical 2 C minus 1. So C minus 1 is equal to 2 divided by 2 radical 2. Those 2's cancel out. 1 over radical 2. Made a mistake. This is the square root of C minus 1. The square root of C minus 1. So now I need to square both sides. And I get C minus 1 is equal to 1 over 2. That's 1/2. So C is equal to 3/2. So now I'm trying to find the point. So I have my C value. What I need to find is F of C. So if I know what C is, I know that C is equal to 1/2. I need to take that 1/2 and evaluate it in my original function. F of x equals the square root of x minus 1. So F of C equals the square root, sorry again, this is 3/2, the square root of 3/2 minus 1 equals the square root of 1/2, which is equal to radical 1 over radical 2, 1 over radical 2. We can rationalize it, radical 2 over 2. So my point here, where it's going to be tangent and parallel to the secant AB, is the point 3/2 radical 2 over 2. Well, I know a point, and I know the slope is also radical 2 over 2. So going into point slope form, I would have y minus y1 is equal to m times x minus x1. I have my x and y. So I have y minus radical 2 over 2 is equal to radical 2 over 2 x minus 3/2. And that should be my answer. Here's my graph on Desmos. I'm going to zoom in on it just a little bit here. I forgot I was also supposed to get the equation of the secant line. So I know that the secant line has the same slope, so I'll use the point, I'll use the point A. So the point A would mean y minus 0 is equal to radical 2 over 2 x minus 1. So y is equal to radical 2 over 2x minus 1. That should be the slope of my that should be the equation of my secant line. So I just type that in, and you can see that's the secant line. Now let's check the equation of my tangent. There I just put in the equation of the tangent, and they look very parallel to me, so I'm satisfied with this answer.